Good evening. Thank you all for joining us. My name is Allison Patillo, and I am with the Aspen Times, and I, along with Peter Bauman of the Post-Independent, are thrilled you all are here. So thank you. I'm as eager as all of you to learn more about maintaining mobility, balance, and athleticism throughout life. I don't know if you noticed, I did come out here with a cane. It's temporary, but I'm all the more eager. On that note, I did have several mobility tests planned for us, but since I can't participate, I don't think that would be fair. Plus, we don't have a whole lot of extra room tonight, which is a great thing, so we'll skip the mobility tests. Instead, and since it is Active Aging Week, I'm going to give you a couple of bits of inspiration. So just yesterday, 104-year-old Dorothy Hoffner may have set the new record as the oldest skydiver in her tandem jump yesterday. So there's that, right? Then for another one, Dot Sowery, I think it might be the name Dot and Dorothy, I think these are some tough women, is 90, and she just set the new American women's record in the half marathon in Chicago in September in the 90 to 94 age group in 3 hours, 33 minutes, and 47 seconds. So that is something for all of us to aspire to. So looking for a lot of good insight from you guys tonight. Then before introducing our panel, I want to thank the sponsors and partners who help bring this event to the community. Those include Compass Peak Imaging in Glenwood Springs. I am a customer, they're great. To call for this wonderful venue and renew senior communities. Then, for our panel, these people have done lots of amazing things and have incredible work going on. So I'm going to give a brief intro, and then they can tell you all the exciting things. So first, we have Jennifer Stevens-Lapsley, who is, among other things, professor and director of the Rehab Science PhD program at the University of Colorado School of Medicine. Then we have Bill Fabricini, who is a Valley resident and a clinical specialist in orthopedic sports therapy and a sports performance coach. And then on the end, we have Dusty Anderson, who is a doctor at the, woohoo! Awesome, so you better ask nice questions, softball questions for him. He is a doctor at the Stedman Clinic, where he specializes in non-surgical modalities to get patients back to peak performance. And then, as our moderator, we have Lee Touchfarber, who is founder of Renew Senior Living Communities, and is an advisory board member of both the Noble Institute of Healthy Aging at DU and the Neuroscience Innovation Initiative at CU. So, with that, Lee, I turn it over to you. Thank you all.
Thank you very much, Allison. So really impressive crowd here, really, really impressive. So thanks for coming out. I want to start with an audience poll just to get a sense of who we have in the audience. So I've got a few questions. So raise your hand if you're under the age of 50. Okay. All right. Small percentage of the audience. Okay, now raise your hand if you're 51 to 70. Okay, and then if you are 70 plus. Got it. Okay, very interesting. So next question is, raise your hand if you exercise like 0 to 1 times per week. Now raise your hand if you exercise 2 to 4 times per week. Okay. And then lastly, raise your hand if you work out, if you exercise 5 to 7 times per week. Okay, wow. Very, very fit audience. Yes, applause to that. Okay, and then lastly, raise your hand if you think that you can't gain muscle strength after you enter, say, the last third of your life. Okay. Okay. All right. So, so let's begin. Jennifer, starting with you, if you could, well, actually, let's go across. If you guys could provide a little bit of depth as to who you're working with today and what exactly you're doing, say, at the University of Colorado, et cetera.
So I'm a physical therapist, and I oversee a group called the Restore Group at the University of Colorado that's focused entirely on how to maximize mobility in older adults. So we're looking at questions on a wide spectrum from patients who've been hospitalized to patients who want to go back to skiing and lots of recreational activities, all looking, very closely at ways we can speed up the recovery process and enhance the rehabilitation that people are receiving.
Bill, go ahead.
I started in Aspen in 1990. I started off in the Aspen Club, a physical therapy clinic, mostly working with orthopedic injuries. As we all live in Aspen, ski time, it's the ACL, back injuries. And through that time there, it was a blessing that I got to see patterns over and over and over. Why are there certain consistent patterns you see when someone might be tearing their ACL regularly, or why are certain back things happening, or hips? And that information and patterning those things helped me in my career moving on to sports performance. I was meeting a lot of athletes in different sports, from tennis to basketball and football, and doing a lot of traveling. But it kind of evolved into working with older folks. I've had some people in the audience who've been with me for 30 years, and that's led into this concept now that we're all excited about, is longevity. Can you continue to train at levels and move at levels that you did when you were younger, and use what we know about the body to sustain a high level of fitness and movement ability?
I work at the Stedman Clinic in the Stedman Philippon Research Institute, which is just down the block. We also have our mothership in Vail. My training is in non-operative orthopedics, so my subspecialty is physical medicine rehabilitation. That's why Bill and I work so closely together. We're both focused on maximizing function. And then I have a fellowship in pain medicine, so we can use interventional tools such as injections to help people maximize their level of function by decreasing their pain.
Thank you, everybody. Okay, so Jennifer, just to start with you. So Colorado ranks number 2 in terms of physical activity for adults age 65 plus. So number 2 in the nation. We actually had the debate over who is number 1. It's not mentioned in the report we had. So if someone wants to look that up and let us know, we're curious as well. But so given that, tell us about what happens as people age, what happens physically to them. What is that process, and sort of what are the implications on their physicality and functionality as they age?
Yeah, there's a number of changes that happen with aging, and the biggest one is the loss of muscle strength or muscle mass. And after the age of 60 to 65, individuals lose a little bit less than 1% of their muscle mass per year, which translates to 2 to 3% loss of muscle strength. That's assuming you're not actively trying to counter that loss, right? So you can certainly strengthen and build and exercise and prevent and slow that loss. That's probably one of the things that people notice the most. There's certainly changes in balance and changes in sensory function, cardiovascular changes as well. But the strength is one of the things that my group has been really focused on, just because, individuals go from one day being able to get out of a chair and the next day realizing that threshold, we call it like the threshold of independence. Suddenly they can no longer get out of that chair independently, and it happens quickly once you approach that threshold. And so how do you prevent that? How do you maintain muscle mass? How do you maintain muscle strength? And the strength loss, it happens at a faster rate than muscle mass loss because you have neural contributions to strength. So it's not just the loss of the muscle tissue, but it's the inputs from the nervous system that stimulate the muscles to contract, and you lose some of the connections and the ability to recruit those muscles as efficiently. So it's that combined loss of neuro and muscular size that contributes to that 2 to 3% loss in strength per year.
That's really interesting. So it's not just the actual muscles themselves, it's also the neural activity. The brain is actually causing diminishment. So Bill, do you have anything to add to that? Or?
Yeah, first of all, this is an exciting time we're in, where aging, the science of aging and longevity is really exploding, and that's why it's so great we're having conversations on this. But just to build, and I love being on panels because everything we talk about with muscle, there was a book a while back I was involved with called Younger Next Year with Chris Crowley, and he had a fun way of describing aging in terms of the tide of aging, combating aging. But as we talk about, it's the decay of all the systems of the body as you age. From the system, the cardiovascular system, you get the smallest vessels in the body, the microcapillaries that provide oxygen and blood to your muscle tissues and organs. They shrink, they die without intervention. And as you can't get oxygen and blood with all these growth nutrients, the tissue dies. Just think of a river and the tributaries. If the water doesn't push into the tributaries, the adjacent land becomes dry and dead. And so it is with the body. If you can't get blood and oxygen to your vital tissues, they die. And then you undergo its concept of, we talked about, muscle atrophy. Sarcopenia is the term where you lose actual muscle mass. The protein synthesis, the ability to build muscle, diminishes. And then what happens, you see physically, is the rate of force development, your speed, your power, your ability to exert tension is compromised. You can't control your bones well. If you can't put loads on your bone, what's the secondary thing you see from a bone perspective? Osteoporosis, right? You have to have the ability to exert force for your bones to adapt and grow new bone cells. The other thing that happens as muscle decays and it doesn't grow is you don't produce proteins in your blood, the growth hormone, testosterone, which indirectly is affected by other things, but you start to lose these hormones. So you decay from a hormone perspective. At the cellular level, where all the reactions where you produce energy, the mitochondria, some of you might have heard that term, those are the powerhouses in your cell where oxygen is utilized and energy is produced. You get all this decay from protein agglomeration from food you eat over life and environmental toxins, and the factory shuts down, so you can't produce energy as well, hence you're more tired. And that leads to other variables. Brain cognitive function declines as you lose brain cells. We talk, the big thing in the longevity industry now is the DNA, your genetic code, the genome and the epigenome that turns genes off and on. That deregulates. And if you can't have the precise map of turning genes off and on that regulate protein synthesis to build muscle, immune system repair to repair tissue, inflammation control, things just go wacky. It's kind of like the hardware system falls apart and the software doesn't run anymore. And then you have molecules in your cells. NAD is a big thing in the longevity thing. These living molecules control the regulation of your DNA, and you lose half of that by the time you're 50. So there's this whole decay of aging. But what we're going to talk about is lifestyle choices can influence that to the point you can halt it and in some cases even reverse it. And that's what I'm excited. We're going to share some of our experiences and discussions and how we can actually impact the tide of aging and reverse it into a growth cycle.
So
I'm
I
glad
like
you ended on a positive note there.
Very positive note, yes.
depressing
Yeah,
audience,
sorry,
I'm
there was-
glad
I was
you were
like,
able to
shall we
turn
go
it
on?
around. There is hope.
There's hope.
Let's talk about reversing, because that's pretty compelling, that you can actually reverse the aging process. So to pivot to you, Dusty, tell us about regenerative medicine, which sounds related to reversal of some of these activities in the body. Tell us about regenerative medicine and sort of what's on the cutting edge, what's the latest on that front?
Absolutely. So I loved Bill's answer because he nailed it on a lot of fronts. Taking a larger view of longevity, there's a diverse array of cellular and molecular mechanisms that contribute to decline over time. And we're starting to find certain mechanisms and switches that we can turn on and off and potentially reverse the aging process. So I'm really excited about it, and I think there's been a lot of new research in this space. Obviously, in orthopedics, we're invested in reversing knee osteoarthritis or hip osteoarthritis or tendinopathy. So that's where our focus generally has been. I think the term regenerative medicine is somewhat of a misnomer because we haven't generated the capacity to regenerate cartilage. And that's kind of the holy grail of orthopedics at this point. If whoever does that will win a Nobel Prize. But we have found biologics and compounds that mitigate inflammation and change the milieu of what's going on in, let's say, the joint or at the cellular level. So that generally breaks down into a few categories. PRP, or platelet-rich plasma, is one category. That's where you take your blood out, you put it in a centrifuge, you spin it down. This was kind of conceived in the late 80s, early 90s, because a very intelligent researcher noticed what happens when you bang your knee, what happens when you get hurt. You get redness and warmth and swelling, and why is that? That's blood flow going to the area. What's in the blood that's helping the healing process? They thought it was the red blood cells. It turns out it's actually the platelets. So there are growth factors and hormones on the platelets that allow the tissue to regenerate. So we dialed that down a little further, and we looked at whether there were other compounds, leukocytes, which are white blood cells, either leukocyte-rich, platelet-rich plasma or leukocyte-poor platelet-rich plasma, and started studying that. And like anything in medicine, initially we thought we could use it for everything. The truth is there's very specific indications, and we have to follow the evidence. So, for knee osteoarthritis, works pretty darn well for mild to moderate knee arthritis. Once you get into the severe category, the biologics tend not to play out as well. The other big category, I would say, for regenerative medicine is stem cells. You've probably heard a lot about stem cells. They're cells that have the capacity to turn into different tissues. So I worked at the University of Wisconsin when I was an undergraduate in the lab next to James Thompson. He shared the Nobel Prize with Nakayama on reverse engineering skin cells back into induced pluripotent stem cells, which had the capacity to differentiate into different tissue. And so this is something I've been at for a while and been interested in for a while. And stem cells are typically obtained from two sources. Either they're obtained from bone marrow or they're obtained from adipose tissue. We found moderate level evidence for, again, mild to moderate knee arthritis, just to keep that example going. And I think there's a lot of ins and outs and permutations on stem cells that you need to be aware of. First, is it a good thing to put a cell in your body that can divide into anything? Turns out it's very safe as long as you don't manipulate it, as long as you don't add anything to it, as long as you don't expand it. And in Aspen, I have this conversation about once a week. Should I go to Costa Rica? Should I go to Panama to get stem cells? Well, the FDA has specific rules on what we can do in this country based on safety data and efficacy data. You can't expand the cells, and we found there's data out of Mayo and data from the FDA that when you multiply a cell, it's called a passage, and by 2 or 3 passages, the cells are kind of Frankenstein. They're not necessarily healthy. And the second thing is when you take 1 million cells and you turn it into 10 million, you do get more of the quote-unquote good, the anti-inflammatory modulation, but you also get more of the bad. So I would say be cautious about going to Costa Rica, and I've had patients spend $30,000, $50,000 to go to some of these clinics. Just do your research, know what you're talking about. And I would say the most exciting thing is actually in the adipose, fat tissue. We've been using bone marrow, and so when I do a stem cell injection, I drill into the pelvis, and it's a loud drill, so I'm sorry if some of you in the audience have experienced that, but and then we spin it down and we re-inject. You can actually obtain stem cells in a higher quantity from fat tissue. So that's a new avenue of research that we're looking into, and I think potentially has a lot of promise.
Really interesting. So you're saying do your research before you go to Costa Rica or Panama for a medical procedure.
Yeah, exactly.
Okay.
You'd be surprised, Lee.
Yes. And hey, I see some people raising their hands, maybe they have questions. We're going to do an audience Q&A after we do some of this back and forth in the panel. So just note to self there. So Jennifer, you've talked about gait speed and how you can maybe quantify it to determine or to predict how long someone will age, how long someone will live. Tell us about that. That's pretty interesting.
Yeah, so Stephanie Studinsky at the University of Pittsburgh a number of years ago published an article that they had looked at 35,000 people, older adults in community dwelling environments, and they looked at their gait speed and they looked at how long they lived. And so they monitored people over time. There are a number of studies that kind of have further supported some of this work, but gait speed is remarkably predictive of mortality. And the reason is it's a measure of a lot of systemic inputs. So I was watching all of you coming in, watching how fast you were walking, and I'm guessing that you're going to be walking a lot faster to your cars on the way out. But it is very predictive of mortality. And it turns out that when you have a change in your gait speed, a lot of times that's more detectable than the underlying medical condition that might be contributing to that change in gait speed. And it might be that you have 3 things that are contributing to a decline in gait speed, and by themselves, you wouldn't identify each one until they become more obvious or a bit more prominent. But together, they can slow someone's gait speed down. So it's remarkably predictive. The good news is it's also reversible. So we know that people, there was a study, they looked at individuals over 9 years, and they actually looked very closely in the first year at whether or not their gait speed increased, went up and down, so transiently improved and declined, or declined. So 3 categories. You either increased, you kind of went up and down, or you declined. And it was remarkably predictive 9 years later of the percentage of those individuals that were still alive. So if you improved your gait speed, you had a greater chance of being alive 9 years later. If you went up and down, you were kind of in the middle. I think it's like goes like 70%, 60%, and then 50% of individuals were alive 9 years later, if your gait speed had declined during that first year. So it's really an interesting measure because it does take into all these different these different factors. And I've had people. I had one person I present often on gait speed and some of the predictions and the analytics associated with it. And so they installed a gait speed sensor in their parents' hallway. And you don't need something that sophisticated. You can take your phone, you can download an app that will measure your gait speed. You mark out a 4-meter walkway, and you can time how fast you're walking. But they had gone to the lengths of having a sensor system installed in the hallway of their apartment complex.
Wow.
And they noticed one day that their loved one's gait speed had declined. We say 0.1 meters per second or more change is a decline. And that value is linked to lots of, higher risk for rehospitalizations and all sorts of things. There's a lot of data to say 0.1 meters per second is kind of that threshold. And they saw that decline and took their loved one into the physician's office who diagnosed them with a medical condition that was intervenable upon. But they were able to detect that earlier than they might have otherwise. So it's a very simple measure, but it's highly predictive of lots of other things. And the good thing is you can do something about improving it. You can strength train, you can exercise, you can do lots of things to preserve your gait speed.
That's amazing. That's amazing that research is out there. So again, I think it's really compelling that even though there are these sort of forces that maybe can cause some decline, that you're able to reverse them. So one of our goals here, just convening tonight, is to pass along some tips, tricks, advice, suggestions for how you can go home and, actually work to reverse some of these forces of nature that are out there. So on that topic, Bill, there are different exercises we all do. And there are a million different viewpoints on, doing yoga, doing Pilates, right? Walking every day, or going beyond that. What do you advise people to do to focus on to really counteract those forces? What should they be doing?
Yeah. Well, first, to Jem's point, I think the point there is the body, the nervous system in particular, is very adaptable, and that is an incredible thing that we can all make changes. It's beautiful. I think the first thing regarding the question is, obviously my general answer is do what you're passionate about because that's what you're going to do. But there should be some definition in defining what is strength training, what is strength. And if you read any type of just workbook, you probably get 20 different answers. What I've evolved strength to be is the ability to project force through the body. And that can be picking up groceries and putting them over your head, the ability to get into a low position, pick the weight up and lift it up. It could be serving a tennis ball. There's different forms of strength. There's speed strength, like watching Roger Federer serve a tennis ball, which is very different than watching an Olympic lifter lift 300 pounds off the ground. That is a different form of strength, maximizing the weight, heavy weights. Strength, but the one thing they all have in common, whether you're using yoga or Pilates or weights, you are projecting force through the body. The question is, how well can you project that force through the body, which is a function of multiple variables. Flexibility. If you can't get into low positions with good posture, you can't move well. You round your back. Some of the hardest athletes I've ever worked with or try to help are ex-bodybuilders who are big and bulky, but they don't have any hip mobility. So when I have them try to pick something off the ground, they round, or their shoulder, they've lost shoulder motion from years of just doing bench pressing, and they have these. So flexibility is critical. Well, what great avenue to develop flexibility? Things like yoga. Core stability is essential because if you can't control your spine position, you dump into bad postures. You hyperextend, you hyperflex. Pilates is a great form to develop the stability to control your spine, which feeds nicely into other forms of strength training, whether you're using weights or doing versions of track and field. Anything that can help you project force through the body efficiently is going to work well. Now, here's the one thing with age, though, that I've added to that. There's different muscle fiber types. There's your aerobic muscle fiber types, type 1. And if your goal is just to have flexibility and move better, something like yoga will do very well. However, to get into these type 2 fibers, which are your bigger, thicker fibers, which are more responsible for creating force and tensionability and size and development, and as you develop muscle fibers, there's a lot of benefits to it. It's not just the muscle itself, it's bone. You create more bone as you use your muscles, but there's hormonal changes in the body. There's nervous system changes. As you work heavier weights, you start to recruit more muscle mass, and you start to have other changes. Nervous system-wise, your nervous system lights up like a light switch, lighting up more lights. The voltage goes up. These are all positive adaptations in your body that affect every system in your body, from your hormones to your brain activity to your brain cells. There's this whole array of things that happen. So to get into these higher type 2 fibers, you have to go a little heavier. You just have to do it safely, and that's where coaching is involved. You might also have to enhance velocity, moving quicker, jumping, things like that. Of course, that requires training. You just don't want to take someone who doesn't have any experience jumping, an 80-year-old person, and have them jump. Many of my clients who are 80 are jumping and they're doing ski drills, but they've been doing it for 30 years. So it's all about proper coaching and adapting into higher thresholds of movement. But the general answer is they all have a purpose. Whatever genre you like, yoga, Pilates, strength training with weights, CrossFit, running at the track, they all have a purpose of coming together. It's just what is your objective? And if you want to really highlight the benefits of trying to stay with some muscle mass, it requires just a little bit more higher threshold of pushing the body with a little bit more weight. It can be your body weight or a little bit more speed. Those things so you can project force better, faster, be more explosive, reduce your risk of falling, improve your reflexes and reactions. It's just a little higher threshold that you might need beyond something than just, say, yoga or Pilates.
So
Can I add to that?
Yeah, please.
That was an excellent explanation. One of the things that I see a lot is when it comes to strength training and targeting those type 2 muscle fibers, those are the ones that are predominantly in your quads and your hamstrings and some muscles in your calves and your biceps. And these are the power-producing kind of muscles that are essential to maintain as you age. And one of the things that we see people do is 30 repetitions of a squat isn't going to necessarily build strength to the same degree as 8 repetitions at a higher weight, where you actually can't do the 9th repetition. So more is better in terms of weight, but less repetitions. And I see this a lot, and we train our therapists. If a patient can do more than 8, up the weight or the level of difficulty. And so that way we're really training into a zone that builds muscle mass, that actually hypertrophies the muscle, if that's the goal. If you're training your core muscles, you want endurance. You want to be able to sustain, and you want to be able to do more repetitions with lesser weights and be able to develop those type 1 muscle fibers in your core musculature. But if you're talking about a lot of these power-producing muscles, if you can do more than 8 repetitions, up the weight.
And generally the vagueness in that is both of us come at it from a medical physical therapy background, is the other question we always have to ask is, what is the margin of safety? And that's the question Dusty has to deal with every day, because if he's going to inject someone with their spine because they've got a degenerative disc, and we try to have them do weight training and they're not prepared for that, they can get hurt. So you have to have those elements of the proper flexibility, motion at the right joints at the right time, stability of the core, and then we can load you safely. It's all about how can you load someone safely, whether it's with weight or with speed training. It's the margin of safety, and if you train properly over time, the window expands dramatically, and we somewhat can become unlimited in the way we train you, even at 80, 85 years old.
So there's something I want to unpack there because I find this really interesting as well. So there's the fast twitch muscles that it seems like if you can penetrate, if you can do the right resistance to activate those fibers, there are other benefits. What are those benefits? Another way of putting this is why would someone, it's harder to work out that way. So what are the incentives? I mean, what can someone expect to get out of it, either cognitively, physically, with respect to longevity? What happens when they really start engaging those muscles, and let's say they're 7 years old?
I'll let you start.
Okay. Yeah. So again, from the nervous system perspective, as you engage these thicker diameter fibers that can generate more force, it requires, again, the voltage, the central nervous system, brain to spinal cord to the peripheral nervous system. You recruit more fibers. You train your body to recruit more fibers at once, which means what? Your reflexes and reactions are heightened. You move faster. It correlates to a better gait. It correlates to speed. You ever see a sprinter, what a sprinter looks like? Even a young, they're ripped and they're lean and they have the most beautiful posture. I love watching track and field athletes, that aesthetics. Now, and even though we can't go back and quite look the way we did when we were 25 years old, there's something to be said about training like that with speed and power to turn on the light switch in our body. And that indirectly turns on the hormonals. So you have growth hormone, which stimulates with vasodilation. I call it, I always say someday I'm going to write a book on most of this, and I'm going to call it All Systems Go. Because what happens is every system in your body kicks in, nervous system, brain, cognitive function. Navigating your body through space with force and speed is highly challenging on the parts of the brain, the frontal cortex, that maps motion. You produce brain cells. It's remarkable how every system turns on as you load the body. But it has to be loaded safely. You have to have the margin of safety to do that. That goes back to, again, balance, flexibility, stability, good posture. These are the foundations of movement. When you have these things, the sky is the limit. You can load. And you can load with speed. You can load with balance challenge. You can load with weight. You can load with all different types of resistances, from tubing to dumbbells to barbells. It's remarkable what you can do with the right training and the right foundation. Please.
Well said. I can't top that. So I think we'll leave it at that. I guess I could say one thing. I agree 100% with everything you said. We're also doing kind of high-intensity resistance training with this 8 to failure principle in individuals who are in nursing facilities, right? So these are individuals who don't always have the flexibility and all these things. We have to be very careful, like you said. But we've been very successful at reversing some of the problems associated with aging, even in individuals who have significant declines in mobility. We've taken individuals who are 95 years old and put weight vests on them and taught them how to do sit-to-stand activities so that they can strengthen and train the muscles in their legs, and they tolerate it really well. But you're absolutely right about everything you said about the flexibility and the form, and all those things are important to prevent injury. And being able to balance and those competing priorities.
Yes.
I find that fascinating. Weight vests on older adults in a senior housing setting. That's really, really impressive.
Not even senior housing, but like these are people who've been hospitalized and are, they're building back their strength, right? And
that's great to know.
They're capable.
Okay, so Dusty, you work with a research group at Stedman. It's part of what you're doing, and I know that one area that you're focused on is the concept of senescence. If you could tell us about senescence, what that is, and also let us know what you're researching. I think there are some compounds that you've discovered that have an interesting impact.
Yeah, I think senescence is a fantastic mechanism that we can implement to reverse aging. Most of the work has been done by Dr. Heward, who's our chief scientific officer. He's a fantastic mind. And I just want to say from a high level, it's one of the mechanisms of aging. There's so many mechanisms that contribute, but we found that this is one of those switches that we can potentially flip. So senescence is Latin to sleep, and we found that there's these cells. Most cells undergo 12 to 15 divisions, and then they're recycled by the body, the circle of life. But we found that there's a percentage of cells that stop replicating and stop functioning as a part of the system, and they kind of fade into the background. And they're actually hard to detect. We've figured out a method to detect them and stain them, and realized that they're not so benign. These aren't cells that have just retired and went to Aspen to have fun and ski. These are cells that are actually quite toxic. They release inflammatory mediators. They're like the car on the side of the road that's just spewing smoke into the air. And they're really associated with a lot of bad things. So this is, again, research out of the Mayo Clinic, some of the stuff that we've done, but there's an association between senescent cells and Alzheimer's and dementia. There's an association between cardiovascular disease. There's an association with osteoarthritis. So it seems like there's potentially this one little central mechanism that has all these spokes that could be contributing to aging in general. Obviously, we're focused on leveraging that for orthopedics. So we started looking at a way, first, how do you detect these cells? It turns out there's a cell differentiator, a CD marker, that you can use to detect senescent cells. So, that took, a couple of years to figure that out. And then we started looking at measuring those in different populations. So taking people from 0 to 100 and measuring how many senescent cells. And guess what? There's almost a linear relationship between how old you are and how many senescent cells you accumulate in your body. So this is how science works. We start, can we detect it reliably? Can we measure it reliably? Is there an association with aging? Now next step was to look at, can we decrease it? So we took about 12 different compounds and we tested all of them, and one in particular I'll highlight tonight. And we put patients through the ringer and had them take the supplement, measured their blood before, measured their blood after, and we found out we could decrease their level of senescent cells by, on average, 93%. It's a plant-based flavonoid. The compound is called fisetin. You can take it at low doses. It's derived from strawberries. Very few side effects, if any. And the next step is to say, all right, can we prove to the scientific community that this works and publish a paper that everyone's going to believe and they can critique it to their heart's content? So currently we are doing a randomized controlled clinical trial. It's active and live here in Basalt and Aspen, where we have different dosing regimens that you come into the study, you don't know what you're getting, I don't know what you're getting, only the researchers know what you're getting, and we measure your senescent cells at different intervals and see if there's a dose effect or an effect of a certain dose versus placebo. So it's an elegant study, it's safe. I think we still have a few spots left if anyone's interested in talking to me after the study. We're hoping that we can lend more credence to our hypothesis that we can use this compound to decrease senescence. That's not the end of the work. The work in science, you're drilling, and then you just keep drilling, and then you just keep drilling further. So we're hoping to leverage that for, outcomes after knee replacement, enhance the efficacy of the injections we do, enhance the efficacy of the biologics, the PRP and the stem cell that we use. And there's so much interesting data. We have data on basically cleaning your cells. So we talked earlier about how you can't take your cells out of your body, like if you're taking stem cells, you can't take them out of your body and manipulate them or add anything to it. But there's no rule that you can't enrich the soil beforehand. So, one study that I'm really interested in doing is putting people on a program before we draw their bone marrow or draw their adipose tissue, and then testing it against a control group and seeing if there's a difference in the quality. Because if I had, for instance, a 93-year-old patient, one of my best friends, funny to say he actually is, I'm going to the East Coast to visit him, all he wants to do is play tennis all day. If he's playing tennis, he's a happy camper. And he had a wrist problem, and absolutely not a surgical candidate, has tried everything under the sun, steroids were not working. And we had a conversation. I said, my friend, you're 90-some years old, and your cells are 90-some years old. And I said, wouldn't it be great if we could make your cells look 18 years old and then put them back in your body? So I think that's one of our potential future directions. I hope I answered your question somewhere there in there, Lee.
No, that was really good. So if I'm understanding clearly, you're doing research on a compound called fisetin, right? And the idea, the hypothesis is that it will enhance outcomes for people recovering from injury. Does it have any potential for people that aren't injured and just want to utilize the supplement for the anti-senescent benefits?
That's a great question. I think we have the data is robust enough for me to tell you. I know it can reduce your senescent cells, but the data is not robust enough for me to say, I know this is going to help you with your pain, or I know this is going to help you with your memory, or I know this is going to help you with your heart. That's kind of the next step in the next phase. So if we cross this threshold and publish this data, I think we can start to venture into that territory. But in science, to make a claim, anything that we say on the stage, it's backed up by strong evidence, and evidence that we can be criticized by our jury of our peers. So we look at things in terms of quality of evidence, and we always look for high quality evidence, meaning you could publish it and someone in Kazakhstan or Australia or London could look at it and say, that's a high quality study. They did everything by the book. They did it perfectly, and they proved objectively that it works. Science is not something you can just live on a wing and a dream. You have to be able to replicate it. So if I did a study and someone in 10 years in India wants to do the same study, they should get the same results if what we did was true.
That's good to know. So there's obviously a lot of scientific rigor that goes into anything that you mention about this. Bill, there's something that I've recently come across, and I know you're familiar with it, is blood flow restriction training, BFR training. Now, I don't know if anyone in the audience has heard of this. There's sort of some literature out there. Can you tell us what that is? And
show of hands, anyone has used BFR in the audience? A few of you, yeah. Yeah, it's a Japanese history with it, and it kind of feeds into the topics Jennifer and I have been talking about of how you can, with loading, recruit. There's two ways you can get into these fast twitch muscle fibers. One is pushing your body with a heavier weight, and the second and third is pushing towards failure, because the body works on a principle of small to large fibers. So you recruit all the small ones before you get to the big ones, the fast twitch ones. The other way, and this is where BFR, blood flow resistance, comes in, is metabolically. You create, we've all worked out and hiked a mountain or skied down where you get that lactate burn in your thighs. So visualize you have a tourniquet, and you never want to tighten these things to the point of tourniquet, but you're creating a backflow of blood. It's a strap, two straps, you pump them up. For the legs, it's about 300 pounds of pressure. The shoulders, about 250. And it creates a backflow of blood as you're exercising. That creates a lack of oxygen. It creates lactate buildup in your blood, acidosis. As your blood becomes acidic, it correlates with growth hormone. It correlates with a lot of protein element synthesis that leads to growth, the opposite of decay, combating the tide of aging. So through these exercises, and the reps with metabolic training are higher. You don't have to use as heavy of a load, which works really good with injury or just in general, because if you can't load because of an injury or you have arthritis in your knee, you have to go lighter weights. But the substitute way of working around that to get into these type 2 fibers and create more growth is metabolically. So you create this backflow of blood in your legs or your arms, and you create these growth factors that lead to muscle development, greater size, and all the positive benefits we've talked about that go with muscle development, from improved force output, improved balance, improved reflexes and reactions. It's an incredible tool. We use it a lot in the rehab, but I use it with a lot of my strength athletes. The U.S. ski team is really big on this. Bodie Miller loves BFR training. He used it quite a bit. Cyclists are using it. Some of the top national cyclists are using it. They do 20 minutes of spin on a bike, and their legs, they create all these enzyme adaptations in their muscles so they can flush out lactate. And if you can flush out lactate quicker and better, you perform at a much higher level and you have an advantage over your competitors. So a lot of applications to it, but incredible aging, for combating the tide of aging tool.
Yeah, I often describe it as, you're tricking your body into thinking you've hit that failure point. You're essentially making the body think that it needs to generate more muscle tissue to not hit that failure point or that lactic acid buildup. So you're essentially overriding the natural process. And it does seem to be very effective in many populations. However, we were talking earlier about it's something that does require some supervision. You can go out there and you can buy a BFR cuff, but there are pressures and different things that you should be considering as far as limits and guidelines. So it's not something that one should be cautious about just going out and using it without any knowledge or experience.
In the fitness field, and we're a very fit audience, everything's in trends. It's like, oh, BFR is the new big thing. Are you doing your BFR? And then, and then it switches to something else the next week, electromuscular stimulation. Are you doing this? And then, everything goes in trends. And in the end, they're just tools. There's always going to be a different trend. It's how you use it. And it's a tool that can be used positively to improve the way your body functions, to get stronger, to combat the tide of aging. In the end, it just requires good coaching and proper education, and you get great benefits with it.
So if I'm understanding correctly, when you do BFR training, you trick your body into thinking that it's sort of reached that failure point. And Bill, you were mentioning that, so the acidity of the blood, the lactic acid that builds up, that burn that I can't stand, but no pain, no gain.
Yeah.
When that happens, that's sort of where the magic is. Am I wrong on that?
No, you're correct. And that's why, again, it's back to, and that's, you can go with lighter loads because you're creating a backflow of lactate, but that's where the blood is acidic. As the blood is acidic, you create all these enzymes. Enzymes are organic compounds, proteins that are involved with chemical reactions that produce growth, cellular respiration, back to your mitochondria function, producing energy. All these things go on the rise, so you can produce more energy. You get all these adaptations. But the one that's really, I think, relevant, that, if I had to pick at the top of the list, it's hormones, growth hormone. And that doesn't just stay localized to your thigh, or if you're doing leg training, it circulates through your body. And growth hormone has incredible impacts on growth, cellular reproduction, tissue repair, wound healing. It's dramatic, and not to mention the nervous system adaptations as well. So that's why the point is you hit it, no pain, no gain. There's got to be some pain involved. But it's not joint where, we want to distinguish, it shouldn't be joint pain. If your knee is killing you after you do this, you got to stop. It's the lactate pain that's temporary that produces these changes. And then, of course, you cycle it out or you move and the lactate flushes out.
So I've got one more question, and then after that we can flip to an audience Q&A. There's a mic on either end, in either aisle. So I just want to kind of go down the panel here. There's another kind of new, I don't know if this is just a temporary trend or if there's something really there. Maybe you can help answer this, but cold exposure. I've heard about it, I've read a lot about it, cold exposure, going into very, very cold water. What happens there? What do you guys know about that? And should older adults be trying this out to see if they can achieve the same benefits?
Well, it's cold exposure, and interestingly enough, there's also heat exposure too that's thought to be protective. So like sauna therapy, like they've done studies and they're starting to see patterns and trends that also may be therapeutic and beneficial. But in terms of the cold therapy, Bill is our physiology expert in terms of the mechanisms of how that's actually working. But again, building that resilience, like almost looking at failure in a different way, like the extremes, and building the body's capacity to bounce back, increases that plasticity inherently, the ability to just to adapt essentially by going to either extreme.
Yeah, and I'm a geek when it comes to this stuff. I find it fascinating, and I can't dive into it enough. So Wim Hof. Are some of you familiar with Wim Hof, the crazy guy, the European who hikes up Mount Everest in his shorts and can control his body temperature, and he has this whole thing. And it correlates also with the Navy SEALs, these guys who are doing incredible things. So the physiology, so to speak, and I find this fascinating, so I'll share with you. Our nervous system, you have a sympathetic drive and a parasympathetic drive. Sympathetic drive, evolutionary, is what we needed when we were being chased by a lion or a dinosaur or whatever, you get the point. The fight or flight response, where your adrenaline goes up and your hormones and your blood vessels constrict. And it's good. You need these fight or flight response, and you get greater muscle activation. It was a survival mechanism. And then the parasympathetic, which we do in meditation, the breathing, and it vasodilates your arteries, and it's healthy, it's anti-inflammatory. So what cold exposure provides is an opportunity to go into a sympathetic drive. Because when you get in a cold plunge or jump in a river, your body goes right to sympathetic drive, right? We've done it. You're in fight or flight mode. You're like, oh, crap, get me the heck out of here. So it's a training tool to do what? How quickly, like a Navy SEAL, can you go into parasympathetic mode? Can you control your breath? Can you get your vasodilation? Can you get oxygen, which is, the molecule that is energy? Can you create the heat in a cold environment, which someone like Wim Hof can do at ease? But he's taught people to do it. So you train yourself especially in our society, where we're always in a little bit of sympathetic drive, social media, whatever, which we know is bad for us. Chronic stress is one of the leading things that accelerates aging. So it's a training tool to learn how to go into parasympathetic mode. And the cold benefits, it's not the cold itself, it's the training benefit of getting into parasympathetic mode while you're in the cold. And if you can learn to do that, that has incredible transfer into your life and all these other benefits of the way, again, all systems go that I talked about earlier. But that's the thing of it. And Wim Hof, of course, has made this famous, where you can go take a Wim Hof class and jump into a plunge and learn how to control your breathing, and you leave there and you feel like Superman. But it's incredible. Here we have the rivers, and I see people in the rivers all the time doing it. But even if you don't use cold exposure, there's something to be said about breath work. And some of you, if anyone read James Nestor book, Breath, I recommend it strongly. It talks about the power of learning to use oxygen in your body, just breathing, and the ability to go parasympathetic, and the benefit of energy exchange of oxygen for every cell in your body, and the benefits of oxygen. It's a fascinating book on just the simplicity of breath work, and you can use that in your training, for strength training, for recovery. But in a society where we live, where we're not even breathing half the time when we don't know it, we're sitting at our computer holding our breath, we're in sympathetic mode. Moving back into that parasympathetic mode, improving our lung capacity, our ability to use oxygen, is one of the most important things we can do to enhance lifespan.
One more question. Just gave me a thought. So Dustin, speaking of books, are there one or two books that you would recommend for the audience on the topic of either regenerative medicine, senescence, reversing aging, fitness? What comes to mind?
Yeah, 100%. So top two would probably be, I think it's Why We Age by David Sinclair. He's done probably the most comprehensive work on longevity. He's out of Harvard and internationally renowned researcher, and does things at a high level, but also explains them at a level I can understand. And then the other book, I would say this is directly related to longevity in the sense that it's about the human project, over the last few thousand years. Enlightenment Now by Steven Pinker. Bill Gates said it's one of the best books he's ever read, top 5. I would agree with that. It's basically about how we can use the principles of the Enlightenment, reason, science, humanism, and progress to enhance human society, and how we have enhanced human society. I think it's just important from a historical perspective to look at, what did you do when you had knee arthritis, 100 years ago? You did nothing. You suffered and you died. What did you do 50 years ago? You still suffered quite a lot, but maybe you lived a little longer. And now we have a knee replacement. which is fantastic. But there are risks associated with that. So what's in the future? Well, hopefully we can restore your native cartilage and get you back to your knee feeling like it's 18. So it gives you kind of a nice spectrum on the timeline of humanity of how far we've come, which is really easy to lose sight of. I don't think that will stop us from pushing where we want to go, but those would be the two I'd recommend.
Interesting. Bill?
James Nestor book, I think Breath is highly recommended. In terms of lifespan, I recently wanted the longevity code. That's the one that will talk about the DNA regulation, the epigenome that controls your gene expression, protein agglomeration, the benefits of fasting to remove the excessive protein in your body that is clogging up your mitochondria from producing energy. It talks about the different things that cause the decay of the body in aging and things you can do about it. And of course, it gets into, and I talked to Lee about this earlier, if we get into nutrition, and we'll hijack the conversation because I've never had a panel discussion where once nutrition comes on board, it's like, okay, we're going down this route, vegetarian, meat eaters. But it gets into that element of the different types of proteins that you get in vegetables versus meats and how that affects the body. But the longevity code, I think it's a fantastic book.
Jennifer?
I guess as a, I'm trying to remember the name of we were talking about earlier, the National Geographic special as an alternative to a book, if you choose a different form of media, it's on Netflix, it's on a variety of different sources. What's that? Blue Zones is one of them, but there was another one. I think they're specifically on aging, going through like cold baths to fasting to strengthening, like kind of a wide range of things you can do to prevent aging through National Geographic. And I thought it was very well done at a very lay audience, but very informative, very scientifically based way of presenting kind of some of the counter options to aging.
So it was a National Geographic, like documentary.
It's a series, yeah, documentary series. Does anybody? Limitless. What's it?
Limitless?
Limitless. Yes, that is yes.
I like the title.
Yes. Limitless. Yes. Thank you.
Watch it.
Okay, so so there's two mics. Does anybody have any questions? Okay. Yes, please go to mics. There's a mic over there, and there's a mic right there. Sir, I'll start with you.
Yeah, what type of aerobic activity and how much fits into the whole scheme of what you do?
Yeah, the guidelines for aerobic exercise are 150 minutes of aerobic exercise a week at a moderate intensity. And so that's kind of a starting point, for aerobic exercise. And you can go up from there, but trying to figure out how you can get, that base through, like Bill was saying, whatever you enjoy doing. Because it doesn't matter whether it's biking or swimming or running or, you name it. It's about just getting that heart rate up for a sustained period of time. There is more and more evidence suggesting that you can do more interval-based training as well, and for shorter periods of time, and maybe, Bill, you can comment on this, but where you can really go up to 90% of your max heart rate, or, in that 80 to 90% range for 30 to 60 seconds, and then drop back down, and you can do it in shorter periods of time and potentially achieve the same benefits.
Agree that one of the benefits of doing some anaerobic training, as we talked about again, when you go anaerobic generally, you're going with greater intensity, right? So say you're walking up Aspen Mountain, you might be in the aerobic zone where you might be at 70% of your max heart rate, what we call below anaerobic threshold. But what happens if you were to sprint for 20 seconds and your heart rate is up, but just that sprint does what? What changes at the cellular level, muscle fiber level? You go from type 1 at some point to type 2 fiber development. And you get the benefits of all that strength. It's where you cross the line between, is it strength training or is it just high intensity cardiovascular training? The point is you switch over eventually when you fatigue the slow twitch fibers, you're going to go into fast twitch fiber recruitment. And you get that benefit of that lean muscle mass development when you push at higher intensities. And that has massive benefits. So you can get the best of both worlds. I think in Aspen what we find is Some of us just like to go for our long, slow bike ride on Saturday. But during the week, we might say, okay, I'm going to throw some intervals in. And the same with your hike. You go for that nice, slow hike, and other days you're like, okay, I'm going to sprint for a few seconds. You can do both and have a good time doing it.
Go ahead.
I want to thank the participants for coming here tonight. I think it's been very informative. I do have a medical background, somewhat aged. I was first wondering about you mentioning a study you were doing with the strawberry flavonoid. I'd be really curious as if there was an opening and I would qualify as a participant volunteer. I would love to do that. And I don't know who to contact or the people.
I'll send the contact to Lee, and we can get it out to the audience and
Okay.
just disseminate it that way.
And my question is, okay, this comes like back in the 80s. When I started, I was a lab tech. And I was in Steamboat, and there's very serious athletes there also. And you wouldn't believe the amount of people that wanted me to blood dope. Okay. So I started relating that to your senescent cell and the inflammation factors that are in the body, which would be good to flush them out. I guess my question is, if you're using stem cells that has a totipotency, they're undifferentiated, meaning you don't know what kind of tissue or cell they're going to develop into. If that would interfere with the totipotency and the growth hormone factor, because that protein is circulating in the blood. I hope I'm describing this correctly, because this is a little bit above my personal knowledge, let's say.
Just to clarify, you're asking if the anti-senescent agent would impact the potency of the stem cell?
Yes.
Okay. So I think, I'm so glad you asked this question. It's like the perfect little springboard. So first of all, there's, again, totipotent cells, which, can differentiate into any tissue, total potency. There's pluripotent, meaning plural, so they can differentiate into specific tissues, and there's different lineages of cells. So, I worked with embryonic stem cells at University of Wisconsin, and then Bush implemented a law, and I love them dearly, but we had to flush them down the drain. But anyways, that's neither here nor there. So the pluripotent cells are typically what we can induce, so we can reverse tissues into, but they can't turn into anything. And then there's lineages. So the mesodermal lineage in orthopedics is muscle and bone tissue. And so we think that lineage is going to be most applicable to joint problems and things in orthopedics. That would be, again, the bone marrow or the fat. I don't have any reason to believe that if we eliminate senescent cells, it's going to impact the quote-unquote potency of the signaling cells. The truth is, I don't necessarily want what we're calling stem cells to turn into other tissue. I've been using that term, and that's another misnomer. A better term for it is medicinal signaling cells, so MSCs, mesenchymal stem cells. It was Kirkland, Dr. Kirkland out of Mayo, who originally coined that term, and he published a paper basically redacting it and saying they're not technically stem cells. I don't want to get into the ins and outs of that. They're more medicinal signaling cells. That's what we're using them for. We really want the anti-inflammatory milieu. One metaphor that I've used with the patient is, you've got your elbow joint, for instance, and it blew up because you fell in a crash. And it's like having troops in Ukraine. And the lights go out, and Starlink goes down, and the radios aren't working, and there's a battle. And it's total chaos and confusion. It's basically what happens when you have a joint that's degenerative. And what we're doing with stem cells is putting generals on the field to help dictate and signal. They're very smart. You can't beat a couple billion years of evolution. They're smart cells. They dictate anti-inflammatory properties. These cells need to come and heal this. You guys need to start communicating. And so it brings this level of communication that's more sophisticated than anything human beings will ever create, which I think is just absolutely fascinating. I hope that answered your question. I slipped it in there. I don't think the anti-senescent properties will impact the stem cells. In fact, yeah.
Go ahead, sir.
Thank you. Two questions. One, this is an awful lot for all of us to digest. So, is there one-stop shopping? Can we go to Stedman and have a longevity coach? Can we have someone that's going to look at all my blood and look at what I do daily and say, okay, you need to kick up the cardio, you need to lift heavy weights? Is there one-stop shopping? Because I will be dead before I understand all this.
Well, we'll just give you some compounds to make you live 20 years longer. Is that enough time? So, good question. There are some private companies out there that are selling packages, so to speak, and I've heard, again, a wide range, $10,000 for a single visit, and then, up to $100,000 for a premium platinum membership. And I don't mean to be critical. I would say academically, no one's doing it because it's all siloed and no one's really communicating. And I think your question really speaks to the challenge of it, is you need different disciplines with deep areas of expertise. You need someone like me, you need someone like Bill and Jen, and more than that to really implement it at a high level. So I'd say we're in the early phases, but I do expect, in the next 10 years or so, these groups are going to become more sophisticated, and there are going to be evidence-based methods that apply to the aging mechanisms across different dimensions that help longevity.
Okay, my second comment or question is this. I got hooked, don't know if it's a good thing or bad thing, listening to Dr. Gundry, and if you take everything he recommends, he'll be taking 400 pills a day. So I don't get what supplements should I take? For example, according to something I read, UC San Diego says that you got to take 9,600 units of vitamin D it will greatly help you prevent cancer. So I keep reading all this stuff, but if I buy into all of it, I'll be broke. I don't know where to go, but I know I should be taking something.
So risk benefit, your risk of choking might go high enough that your longevity will be impaired.
Or as some people say, I'm going to have very expensive urine.
I knew we were going to have some banter. I knew it. I knew it. So this is great. But the truth is, we do need a level of expertise to siphon it down. So when I went to medical school, the professor said, if you guys spent every waking minute from now for the next 4 years just reading scientific papers, you're going to be 800 years behind by the time you graduate. So our job is to take the relevant, salient, high-level evidence and boil it down and then give you a fire hose to drink from and 10,000 pages to memorize. So I think I'll guide you to some resources. Again, I think these groups and these organizations are going to put it together. How they put it together is what matters, leveraging the evidence. The one that I tend to steer people to is examine.com. It's a free website. You can look up vitamin D, and they actually link scientific articles, and they give you levels of evidence, to help parse it through. They also have, stacks, and I'm sure they charge for certain things too, but that seems to be a relatively legitimate source. Your physician, might be another good source if you want to ask them. But I would say, like vitamin D, 9,600 units a day, that's, vitamin D toxicity is a real thing. And, that could be potentially dangerous. And the other thing I'll say, supplements are unregulated. So drugs have very specific kind of legislature behind them. To have a drug in this country, it's quite a high bar to get there. On average, it takes 10 years and $1 billion to develop a drug. Supplements are unregulated, so we don't always know what's in them. So they did a study. They took supplements from Walmart, Kmart, big box stores, and they tested them, and they found that 1/3 of the supplements did not have the active ingredient that was tested. 1/3 of them had the ingredient in a different dose that was on the label, and 1/3 of them had the dose accurately as described on the label. So for instance, when we were doing the senescence study, we tested a variety of brands for Fisetin, and we found one brand, and there are certifications. Like if you go on Amazon.com and look at supplements, you can see if there's certifications. You might want to look into the background of that organization to verify that it's legitimate. But the supplement companies will say, you can take any product off of our shelf. We believe in our manufacturing process. You can test it. And if we test at the level we're saying we're giving people, we'll give you the stamp and certificate. So that's kind of one way to verify. But I hate saying do your research. But
So you say talk to your doctor.
Doctor's best. Doctor's best.
Doctor, you say talk to your doctor, but you are my doctor.
Exactly. See?
That's that. Just drop the mic.
We're talking right now.
Great punchline. Sir, go ahead.
I graduated from Long Beach State in 1972. And to Jennifer's point, we were doing weightlifting then, and it was 4 sets, 6 reps. So that, and my mistake was thinking that I could play football for Long Beach State. So, and that was the first year Stanglin came over from USC. So that tells you where I went. And then to Bill's comment that when you do lift weights, it's a good posture issue. But what do you do when you have scoliosis? It's not a rehab. It's not an injury. But on the other side is I have a curvature of the back, and the only thing good about it was it kept me out of the Vietnam War. Because when you go down for a physical, they do a chest X-ray, but on the stupid side of me, thinking that I wanted to join the Marines, and so I figured if I stood this way, it would straighten my back, and anyhow, I got rejected, but that's neither here nor there. But so what do you do when you're physically not in rehab, you haven't injured anything, but you have an S-curve, and your posture sucks? So it's like I was taking steroids, Maxabolin and Dianabol in college. I had a 19-inch neck, huge arms, just so I could, fake playing football. But it wasn't, it wasn't conducive to basically making the team. But and the third comment I have is the thought of stretching, touching my toes, I want to throw up. I mean, I'm probably, you throw me in the water and I sink like a rock. It's, I mean, I love to swim, surf, but I've never been flexible. And with bad posture, it doesn't help either. But there's nothing I can do about the posture.
Yeah. First of all, I'm sorry you have to experience something that difficult. Scoliosis is extremely challenging, and all of us in the physical therapy world have dealt with people who have curvatures of the spine in the medial lateral direction with rotational deficits, from children growing up to people where it's been so severe they have to put the rod in. It's a challenging thing. It's a structural thing. But you still use the same basic premises, and this is the difficult thing in a Q&A. You can't answer this in a simple Q&A. Right. It takes time. You said you don't like to stretch and reach your hamstrings, but there are ways you can improve mobility in your joints that would unload your spine. Other ways of mobilizing your hips so that when you're bending, you're not putting rotational forces through the spine. There's stabilization things. There's specific stretches and movements for people with scoliosis. The best I can do in a Q&A is, what's helped me with people with scoliosis is the Scroth method. And that's, it was a practitioner out of New York working with professional dancers, and he designed these incredible movement patterns that would elongate the short side of the spine. And he could literally see, and there's a whole, you can Google it and you'll find all types of it, but he could change the rib cage orientation through breath work. But it takes a skilled practitioner. It's not something, especially, you know, as an elder gentleman, you're gonna just read a book and change this. You're gonna need some coaching and a professional to work with you and use these concepts to feed breath into your spine to create stability and motion that might allow you to move a little bit more freely in space. I mean, you're never gonna, you know, you're always just like someone who has got a severe arthritic joint. You'll never return to full function to the degree you might want, but you can move in baby steps in the right direction. I don't know if you have anything to add to that.
No, I agree 100%. You can think about other muscle groups that you can strengthen, like you mentioned your arms, right? You know, focus on the muscle groups that are less affected potentially and maintain the strength as much as possible in those muscle groups as well. But I agree, there are things that can be done
At
over
76 years old, though, I mean, that's,
Yeah, you can still adapt, you can still build, you can still,
yeah.
you know, it's going to take longer and it's going to be more difficult, but it is still possible to get some benefits from some
Well,
of
I
the
don't want to
techniques
take
that
up
Bill
anybody else.
described.
And Dr. Anderson, check your texts. I've texted you twice. Bob Hightower recommended you hire.
Oh, awesome. You might have my old cell phone. So let's connect after, because I changed it.
Thank you very much. I appreciate your input.
Thank you.
Thank you.
The Scroth method. I'll do the best I can. It's as it sounds. If you just come close to spelling it, Scroth method, scoliosis. It's as it sounds, and I apologize. I can't spell it correctly. Schroth, yeah. That is by far, you know, the most innovative, advanced scoliosis methods I've personally seen, and I constantly get testimony from people who have advanced scoliosis that I use this method, and it's changed my life, particularly dancers with extreme curvatures. The Scroth method. What, Dusty, why don't you spell it for the degree you can?
Schroth.
Okay, go ahead, ma'am.
I just want to thank you all for dedicating your life to this perpetual learning program and sharing it with us. I think my question might be best dedicated to Jennifer. First, I was an 08 CU DPT grad, and I can testify she lives what she preaches because she doesn't look like she's aged more than 30 days in the last 15 years. It's awesome to see. I am wondering, is there a lot of that science out there as far as aging, losing 10% of your muscle mass every decade seems to be a pretty general population research. And do you know of any studies that show at best case scenario with a certain level of activity, a certain level of fitness going into it and activity during those decades, what's like our best case scenario as far as muscle loss?
Yeah, what the attenuation of that can be.
Yeah.
Yeah, there are some studies. There's a group out of Baltimore, and there's a couple groups that have been looking at, you know, how much can you reduce it. You can't eliminate it, but you can absolutely reduce it by at least 60, 70% in terms of the loss. You're still going to have some muscle atrophy that eventually over time, you know, is going to happen no matter what type of training you're doing. But I think, I don't know if you're familiar with any of the literature in that area with a specific percentage as to what you can attenuate, but it's somewhat around in kind of that range. So reason to be optimistic.
Thank you.
And with the right training dosage.
And it's positive. It's just there's so many variables, from your genetics to where you started. There's a lot of variables.
Yeah, I was involved in a study that looked, and these epigenetic studies are expanding. Someone's capacity to build muscle mass may be inherently driven by 90% of it driven by your genetics. Doesn't mean you can't you know, you're doesn't mean you can't alter that trajectory to some degree, but there's a heavy presence in genetics. We looked at patients that had an ankle fracture, and we did a detailed kind of genetic analysis with microarrays and a bunch of other things that help us understand the underpinnings of who rehabbed well and built muscle mass and who didn't. And it was really interesting to see how much of it kind of came back down to their inherent genetic predisposition.
So we have time for one more question because I know some people need to leave. However, if there's anyone else has a question, I think maybe we can stay for a few more minutes. You can just approach the panelists on the stage. Sir, go ahead.
Yeah, short question. Just one comes across things maybe in Time magazine, which is not a medical journal, but I remember a long time ago when scientists were able to increase the lifespan of worms. Now, we're not worms, but then, some of us. But then the latest one I read was taking older mice and rejuvenating them into younger mice. What the hell's going on there?
Yeah, so there's some interesting data on that. Nematodes are a type of worm, and that's detailed in David Sinclair's book pretty well. That's where a lot of this started. We've also done research in our group where we've taken an older mouse and a younger mouse, and I know it sounds kind of gruesome, but you can attach their circulatory systems, and just by introducing the blood flow, assuming there's the same blood type, the older mouse will lose the gray hair and show signs of reverse aging. And we've seen the same thing with some of our senescence research in animals. Animals are genetically similar to us to a very high degree, 99.9+%. Now that little percentage accounts for a huge degree of variation in species across the entire planet. So we always have to translate those animal studies to human work. But I hope that kind of speaks to what you were getting at.
Okay, one more half a question. I have a younger wife who's never met a 14,000-foot peak that she didn't love. Now, at that high altitude, she's got oxygen deprivation. So at what point should she turn around and go back down?
Better suited for maybe Dr. Kilnani, the pulmonologist. Sorry, I wish I could answer that. It's very specific.
Okay, so thank you everybody for coming tonight.
Thank you.
Super fun. All right, everybody have a wonderful evening. Thank you.